Welcome to the Arefco Service Group YouTube channel. Please remember to subscribe and ring that bell to get notified whenever we upload a new video. In this video, we're going to be talking about the heat pump balance point. The heat pump balance point is where the output of the heat pump equals the heat loss from the house. To illustrate what I mean, let's take a look at this graph. On the left, I have BTUs per hour, and then down below we have our outdoor temperature. First, we need to do a heat loss calculation for the house. Here in Seattle, we use a delta T of 50. So we're looking at an outdoor temperature of 20. So we're going to draw a line straight up from 20 degrees. And we've calculated the heat loss on this house. We're going to say 40,000 BTUs per hour when it is 20 degrees outside. So if it's 70 degrees inside and 70 degrees outside, there is no heat loss. So we're going to draw a line from 70 through our intersection point there at 40,000 BTUs and 20 degrees outside temperature and extend that all the way down to 0 degrees outside. So this house, if it were 0 degrees outside, would be losing approximately 54,000 BTUs per hour. But our design temperature is for 20 degrees outside temperature. Okay, in this demonstration, we're looking at, say, a SEER 13 or 14 single stage heat pump. And we're going to calculate it at a 2.5 ton unit, so we're going to draw a line from 42,000 BTUs over, and usually the design temperature on that type of unit is it's going to have 100% of its heat at 47 degrees. This particular unit, when it is 0 degrees, is only putting out 25,000 BTUs per hour. So this is our heat pump output. Where these two lines intersect is our balance point. That makes our balance point right about 27 degrees. But in reality, the output for a heat pump curve looks more like this. And if this were the case, our balance point would be more like 23 degrees. On an inverter unit, the output is going to look more like this. For our demonstration, we're looking at a balance point for a SEER 13 or 14 heat pump to be somewhere around 27 degrees with this particular house. It would change if the house is tighter, better insulated, there's less heat loss, those numbers would change. The heat loss for the house will look more like this, where we're only losing, say, about 31 or 32,000 BTUs at 20 degrees. Then our balance point shifts down. So there's a couple of factors here. You're looking at the heat loss of the house, and that needs to be calculated. So you have to plot these 2 points to determine what your balance point is. In setting up a thermostat with our example heat pump, our balance point here is right about 27 degrees. I like a 5-degree swing on either side. So I'm going to make it so my auxiliary heat cannot turn on until the outside temperature is 32 degrees or less. And at 22 degrees, the heat pump shuts off and it will only operate on auxiliary heat. Between these 2 points, we can have both the heat pump and auxiliary heat on at the same time. That's just my preference. I find that's best when it is at its balance point. The heat pump is running 24/7 to keep up with the heat loss from the house at 20 degrees outside temperature. So that is a heat pump balance point and how you figure it. It's really quite simple. I hope you enjoyed this video. Show us some love. Give us a like, give us a comment. I'm Mark. We'll talk to you next week.